All right, we are going to solve systems of equations. We're going to do it two different ways. First, substitution. Second, elimination. There are plenty of examples of each on here, and I can be happy to give you more if you want, but I'm only going to do a handful of each because I think you'll be able to put it together once you see a couple of them. So the most basic level, substitution says I want to get a variable all by itself. I want to define what x is equal to. X equals something. And then I'm going to take that something and I'm going to plug it into the other equation, and that will help me get my answer. So here, I want to get any variable all alone. It really doesn't matter which one. I'm going to choose to solve for this x. So here I subtract y from both sides. X equals 5 minus y. Okay. So I don't know what that quantity is, but I've defined x. X is 5 minus y. I'm going to take this, and now I'm going to plug it in for this x up here. I'm going to substitute it, just swap it out. So 5 minus y equals 3. Okay. Now I have y all, like just an equation with just y's, I can solve for it. 5 minus 2y, because minus 1y minus another, minus 2, equals 3. Okay, let's get that 5 out of there. Negative 2y equals negative 2. Lastly, divide by negative 2. Y equals 1. Okay, so that's one of my answers. I need to take this 1 and plug it into any other equation. Why not just do this one that we started with here? So it started x plus y is 5. X plus y. We just found out y was 1. X plus 1 is 5. So x is 4. Okay. I got my two answers. I need to put it in a ordered pair as my solution. So it will be the x followed by the y. 4, 1. And that is our answer. All right, let's do number 2. In this one, x is already defined. You have 1 already by itself. Why do more work? Take that. I'm going to take that, I'm going to plug it into the other one for x. And it will look like 2y minus 7 plus 5y equals 7. Okay, I've just taken that and swapped it in. Now I have a little bit of distributing that I'm going to do here. 2y minus 14 plus 5y equals 7. Let's clean it up by combining like terms. 7y minus 14 equals 7. 7y equals 21. Y equals 3. Okay. Now let's plug that in to the other one. And it doesn't matter. Oh, hey, look, x equals. So let's just plug it in for that one. X equals y, which was 3 minus 7. So x equals a minus 4. And that's okay. You can have negatives because all we're trying to find is an ordered pair, and an ordered pair is a point on a graph. And yes, of course, you can have negative x's or negative y's. So our answer is negative 4, 3, because it's x, y. All right, those are two kind of easy ones. Let's go down and maybe try one that's a little bit trickier. Let's do, what was the one that you guys all struggled on? This one, number 10. Okay. Now, it's true, you can get any x or any y all alone and it would be fine. But sometimes there are smarter ways to do things. We try to avoid fractions as much as possible. If I want to solve for this x, if I'm choosing to do so, I could do it and I could probably get it right. But I would end up dividing by 3 at some point to get x all alone, and that would mean I'm dividing a 5 by a 3, and that's not going to come out nice and neat. I'm going to get a fraction. That's gross. So for the same reason, I'm not going to solve for this y, because I divide by 5 and I get a 3 over 5, and that's gross. So I'm not going to use this one at all. I'm going to come down here and see if I can solve for one of these without getting a fraction. if I were to solve for this x, I would need to divide by 4 at some point. And I could put a 4 into a 12, that would give me a nice 3. But if I divided this 2 by 4, that's gonna give me 2 over 4, which is 1/2, and that's a fraction too. We don't want that. So the only option is to solve for this y. That will give us a number that's not a fraction and make this problem a lot easier. Let's get this y all by itself. I'm gonna subtract 4 x's from both sides. And now I'm gonna divide everything by 2. Okay. Now I have y defined and I don't have any fractions. This is perfect. It's so much easier this way. I'm gonna take that and I'm gonna plug it in for this one up here. So let's see, it's 3x minus 5, and then there's the y. 6 minus 2x equals -4. Okay, I have a little bit of distributing. 3x minus 30 plus 10x equals -4. Clean it up. 13x minus 30 equals -4. 13x equals 26. X equals 2. All right. Let's take that 2 and let's put it in to a y equation. And right here we already have y defined. Y equals 6 minus 2 with x. Y equals 6 minus 4. Y also is 2. So in this one, my solution is 2, 2. Okay, so that is substitution. Now let's look at elimination. Elimination needs 2 things. 1, you need the same number in front of a variable, and you need 2, the opposite signs. So looking at number 1 here, there's invisible 1s in front of each of these, a 1 and a 1, a 1 and a 1. So I do have the same number everywhere, but I need opposite signs. So this negative and this positive, that's exactly what I want to see. This is already perfect and set up for me to solve. Once I have both of those situations happening, I turn the whole thing into one giant addition problem and smoosh them together. X plus x is 2x. Negative y plus a y, well, they cancel, they eliminate each other. 8 plus 10 is 18. Now I divide by 2, x equals 9. Plug that back in for either of them, doesn't matter. X minus y equals 8. All right, well, x was 9. 9 minus y equals 8. So y's got to be 1. Answer here is 9, 1. And you might be asking yourself, why would I do substitution ever? Like, this was way faster. And yeah, there are times that's faster. That's why you learn both ways. But sometimes it's going to be easier to substitute too. So I'd like you to practice both ways. Maybe find one way you're comfortable with, and if you want to do that way only, that's fine. But know that sometimes even elimination gets tricky. Look at number 4. Okay? I have a 1 here and a 2 here, not the same number. I have a 5 and a 5. Okay, so same number. I need the signs to be opposite, but they're not. So that's okay. When that happens, I can just make the signs opposite. I can just change this. If I want to change this to be a minus, I sure can. But I need to change every other sign too. Negative x. Actually, let's just do it over here. I'm going to rewrite this down here, but I'm going to swap every sign. Negative 5y, this is positive, so it's minus x. This is already negative, so that's going to become a positive. If I just change one sign, I have to change everything. Now it's set up for my addition problem. 2x take away 1x, boom, cancel. Negative 12 plus 11, that's minus 1. All right, let's go back and plug that in. If x is -1 plus 5y equals -11. Okay, let's get the y alone. Add 1 to both sides. 5y is -10. Divide that by 5, y equals -2. And there's my answer. Okay, that time I had to change a sign. What happens when I need to change the number because the number doesn't work? Number 8. Ooh, way too big. We'll deal with that. All right, I have opposite signs here, but not the same number. Same number, same sign. All right, so now I need to multiply, and it's not very easy for me to turn a 2 into a 5 with multiplication. I could multiply it by 2.5, but that would mean the rest of this is gross. So let's turn a 3 into a 6 instead. That's easy. I can just multiply the whole thing by 2, and that will work. So I'll take the top one, and I'll multiply it by a 2. But that will give me a +6, and I already have a positive down here. I want this to be the same number and the opposite sign. So I'll do 2 things at once, and I'll multiply the whole thing by a -2. So if I do that, -2 will give me -6x. Multiply that out, negative by negative makes positive. All right. Now I'm set up. I have same number, opposite sign, my addition problem. Cancels, 9y equals 45, so y equals 5. Take it and plug it into the other side somewhere, doesn't matter where. I don't know, let's do this one I guess. 6x plus 5 with the y equals 37, okay? 6x plus 25 equals 37, 6x equals 12, x equals 2. So my answer here is 2, 5. Weird zoom in there. Now, what happens when nothing works nicely, like in number 12? I can't change a 2 into a 5 with multiplication easy, and I can't change a 3 into a 4. So now I need to manipulate both equations. And it doesn't matter which one you can do. You can solve for the x or the y. I'm just going to do the y for this example. What is the smallest number that you can multiply to make a 2 into that you can also make a 5 into? Well, it's going to be 10. How do you make a 2 into a 10? You multiply it by 5. How do you make a 5 into a 10? You multiply it by 2. Okay, so that will, at the end of the day, that's going to give me the same number. The reason I chose the y is because they have opposite signs already. So that was already checking one of my boxes. Now if I rewrite both of these equations, the top one is going to turn into 15x minus 10y equals 20. And the bottom one will transform into 8x plus 10y equals negative 20. Something interesting is going to happen here, but that's okay. Let's do our addition problem and combine this. 23x, y's cancel. 20 take away 20 is 0. You might think you've done something wrong, but that's actually okay. Divide by 23, x equals 0. That can happen. Because remember, we're just doing a point on a graph. And you can have a 0, that would be on your axes, right? So plug x in for somewhere. Doesn't matter where. Let's do the top one. 3 times 0 minus 2y equals 4. Alright, well anything times 0 is 0. So negative 2y equals 4. Let's divide by the negative 2. Y equals negative 2. So our solution here is 0, negative 2. So sometimes substitution's easier, sometimes elimination's easier. Really get practice at both, but when it comes test time, do whatever way you're most comfortable with.